important topic over here, that is the type of the support vector machine. And here we have the two type of the support vector machine. Those are the linear SVM and non-linear SVM. I'm going to start the first type of the support vector machine, that is a linear support vector machine. And this linear support vector machine is very simple support vector machine which describe the information following by the hyperplane, of course. But here we have the data in the linear way. And in this point, we can separate the data by the linear approach, and that is known as the linearly separable, we can say. So linear SVM basically used to data that are linearly separable, or we can say data set can be categorized into the two categories by utilizing a single straight line. And this straight line equation can be identified as a y equal to mx plus c. But can anyone tell me how to calculate the distance of the this distance between the two different support vectors? So we can easily determine that is a we have the equation. So I'm remembering equations, so that's why I'm saying here d equal to ax plus by plus c, its absolute value, and divided by the a square plus b square, and that is known as the distance margin. So whenever and divide by the a square plus b square, and that is a formula for calculating the distance margin. If you remember the what you mean by the distance margin and maximum space, that is equation. And hyperplane is definitely followed by the or just change its position by taking the slope value. So that's why we have the straight line equation, that is a y equal to mx plus c. And that concept we have applied over here in the SVM. And that is the point we need to keep in mind while learning the SVM. So such data points basically here we have over here in the circle way or rectangle way into different colors. One is blue and it is followed by the red as well. So what we have, we can divide these two different kind of the data set or data points by a line that is known as the hyperplane. But still we have the question how to choose the best line that is followed by the distance margin, and how we are calculating distance. Definitely there will be some formula, but how we are getting in theoretically I have explained by the images into the previous slide. So finally, in the next image, you can observe over we have the optimal hyperplane, and we have the two distance vector over here. So just let me draw something here for a betterment and for the device purpose. Just let me. So over here by the diagrammatically, so you can observe over here we have the multiple line, but we are choosing only the one hyperplane, and that is known as the optimal hyperplane. Okay. Now tell me any doubt over here. Just tell me any doubt over here.
No, sir.
See, let me clarify this important term. This is the support vectors, and this is the support vector of this data point, and this is the support vector. Okay. So the distance between this support vector and this distance vector is known as the maximum margin, and this maximum margin is also known as distance margin. So I can write the distance margin equations like this one. Here you can observe over here. There will be an equations ax plus b by. Mathematically, I'm remembering equation. That's why I'm saying over here. And there's a fundamental equation we have studied into the 10 standard, 12 standard. So we are not going to deeply part, but we know what would be the equation. So this would be our equation to calculate the distance margin. Okay. And now this hyperplane. So this hyperplane is straight line. So this contains the equations y equal to mx plus c. Okay, that is my point. So this is to be done by the SVM, and in the linear SVM, what we have this point. Okay. Okay, now tell me this linear SVM is clear?
Yes, sir.
Okay. In the non-linear SVM, what we have observed over here so many times we have seen in the non-linear SVM, we are unable to define the data in properly. See, if I'm choosing any hyperplane like this one, like suppose I'm choosing like this one to separate my data, still we can make the one data set one group over here, we can the one class, but here I'm trying to make another group or in the class. Definitely it contains a mixed kind of the both kind of the classes. So I am not filtering my data set properly, or data point we can say. If according to your demands, if I'm choosing like this one, again I'm still unable to find. If I'm choosing this one, again still having problem. If I'm choosing like this one, again I'm having the problem. So at the time what we have, you can observe over here your data points are plotted on the x y axis. Okay, so x and y axis will represent over here. And let me say a few words over here. So in the non-linear SVM, what we have, the data is used for the non-linear separable. That is the point you need to keep in mind. In the linear SVM, we have the linear separable and data that is a, so here straight line cannot be used to classify the data. If you're trying to use straight line, then you are unable to, and you are not possible to separate data properly. That is the point we need to keep in mind. So for solving this problem, we have an important function that is known as a kernel function. Okay, so that is point we need to keep in mind. So what is a kernel function? I will tell you in the next slide. But before jumping that part, let me clear this point over here. This line 1 L1, this line 2 L2, this line 3 L3, and this line L4. This line and another line we have like this one. Suppose I have L5. Any of these line is not possible to separate my data properly. So that's why I have to introduce a new thing that is known as the kernel function. Okay. And what is the kernel function? The kernel function is objective of the kernel function to transform one dimension data set into the its higher dimension data set. Okay, higher dimension data set. And one dimension, if you have the 1D, so we can transform the 2D. If we have the 2D and where the hyperplane is not possible, so we need to 3D. And unfortunately, suppose we have the the 3D data set, and that is not possible to make the hyperplane or classify the data by the data points by the hyperplane. Again, we need to move it's the this point. So this is the point. So we need to keep in mind all these terms properly. And the point we need to keep in mind when we have the linear SVM and we have the linear SVM classification, and that is known as the linear classifier. And we have the non-linear SVM, so that is also known as the non-linear SVM classifier. Okay, this is the term you need to keep in mind. Now, any doubt in this point? What is the difference between linear SVM and non-linear SVM? Now tell me, any doubt over here?
No, sir.
Okay, so you can observe over here in the this point. What you can see, you can observe over here. We have the two axes. One is x-axis and y-axis. So, can you tell me what is the dimension of this data set? Please tell me what is the dimension of this data set. Yes, tell me.
2D.
2D. So we can say we have the two dimension 2D, or we can see the two dimension data set. So here we have the x and y. Okay, and after using the kernel function of trying to transform this data set into the 3D data set to apply the hyperplane properly to classify the my data. So what I'm doing the 3D right now. Okay, but if I'm using 3D, so another axis is required. Here we have the two axes, x and y. So another axis is required, that is z axis. Okay. And the next image or next slide will show this concept right now. Now this image is visible to all right now. Tell me, this image is visible. Yes, tell me, this image is visible.
Yes, sir.
Yes,
Visible.
sir. Yes, sir,
Okay.
visible, sir.
Okay, so the 2D data set we have that is followed by the two axes. Those are the x and y. And now after applying kernel function, now my data set is transformed to 3D dimension. So it contains the x, y, and z, of course. And z, if I'm reading over here, that is z equal to x square plus y square. So I can understand z like this one. And this z treated as a kernel function. That is a point you need to keep in mind. But internally it is managed by the some algorithm, and those algorithm can be identified by the kernel function. Okay, so the mathematically, and we will not go into deeply manner what is the equation, what is the parameter which is used by the kernel function, but we will focus only the name of the kernel function to implement kernel function as our desire. So now after transforming my data set into 2D to 3D, now I can easily mark hyperplane to separate my data. Now you can observe over here. Now you have the Z axis and you have the X axis only. But no, you can't say right now. You have only the two axes. You have the three different axes, X, Y, and Z. By is the behind of the this part. Now on the screen we are able to see only the information 2D manner only. Okay, that is the point we need to keep in mind, and we are not unable to see right now. Why? Because it is backend. It is on the back side of this diagram. So that is not visible by the 2D, and that is the point we need to keep in mind. So after transforming or after rotating by the different angles, so we can able to see by axis as well. But now we can separate our data. Now this concept is clear. This concept is clear.
Yes, sir, clear.
Okay. So this is the idea about the linear SVM and non-linear SVM. So for the examination purpose, I can ask you this question in simple way. Distinguish between the linear and non-linear SVM. So I hope you can write with the help of the example in easy way. So the point we need to keep in mind here we have the some terms over here. So on the close analysis, it is evident that the above data points, it means the previous slide we have seen, can be separated using a straight line function that is either parallel to the x-axis or is inclined at an angle. So different type of the kernel functions are applicable, and we have the various kind of the kernel function that is a linear, non-linear, polynomial, and radial basis function and sigma. So these are the various kernel function which are used to transform your data set into one dimension to another dimension. Not another, you can say the upper or higher dimension. But linear, the term we know, non-linear, we know the term, polynomial, we know the term. But we need to understand the sigmoid, we know the sigmoid. But when talking about the RVF, so RVF stands for the radial basis function. And what is the importance of the RVF? And it is most popular kernel function. Very frankly speaking, in the so many programs I have observed over here, most of the time RVF kernel function is always used. But if you want to use any kernel function, then you can use without any problem. But most of the time, or we can say the 85% approximately, so many programs I have been observed, I found RVF is applicable. But what does it mean by the RVF? RVF stands for the radial basis function. And in this point, why RVF is required? I have written over here. RVF will be the norm of the distance between the dead point and some fixed point. So it calculates the distance between dead points from which we need to calculate the we need to distinguish, or we need to transform your data point, and at some fixed point it automatically does this activity, and that is the beauty of the RVF. So that's why the RVF is most popular. Why RVF? Because RVF, that is a radial basis function, will choose some fixed point and choose the distance between the dead point, and from that we need to classify the data, and that is the beauty of the RVF. So that's why the RVF function is most popular. So these are the few kernel functions we have. Those are the linear, non-linear, polynomial, RVF, and sigmoid. Now this part is clear right now. What are the name of the kernel function? This part is clear. Just tell me any doubt you are having. Please, you can ask me right now. This kernel function is.
Yes, sir.
Okay.
Yes, sir.
Okay. So which kernel function I must choose? That is a big question. Which kernel function I must choose? Because I have the 5 different kernel function, but which kernel function I must choose? That is the big question we have over here. Sir, you have said the linear function, non-linear function, polynomial, RVF, and sigmoid we can choose. Okay, so RVF is better according to you, but we are not saying RVF is better. But I'm saying why RVF is better, because there's some reason. But the point we need to keep in mind, any function in the Python programming, or we can say the machine learning especially, is depend on the data set, very frankly speaking. Suppose you have some data set and you are having the small amount of data set and trying to find the good accuracy, that is not possible. But on same data set, you are training the model with the different kind of the different percentage of the training data set. Definitely, you can have the different or maybe the better or worst accuracy. So depend on the data set, depend on the building the model, following by the training data set. Everything is depend on your how you are building your model. That is the point. But the question is still we have in our mind, why we need to choose this kernel function, or why need to choose the kernel function, and that is a big question. So see, in SVM basically designed for the classification problem. So in the classification, what we have the different kind of the measurement performance criteria, and those are the accuracy, precision, recall. Okay, And other than these one, we have the Z score, we have the F score, and we have the other kind of the parameter. So after founding this point over here, if I'm choosing the linear, so maybe I can get accuracy 70 or something. I'm taking example only, just for understanding purpose only. If I'm choosing polynomial, so maybe I can get the 88. But suppose I'm choosing the for the same problem, I'm choosing the kernel function radial. There may be some chance I can get the accuracy 95 or more than 95%. So definitely I will choose the RVM. So in the SVM, you have to apply the kernel function, then you have to apply the various kernel function to provide the better accuracy your model. That is the point you need to keep in mind. So any one of the kernel function you can choose, and now you need to check which kernel function is giving better accuracy, and that on that parameter you can set the kernel function. That is my point. Now this point is clear right now. Tell me, this point is clear. So which kernel function I must choose? I will check each and every kernel function to check which kernel function providing the better accuracy. So I will keep the particular kernel function for my problem. That is my point. Now this one is clear.
Yes, sir.
Okay. Till now, any doubt, student? Please tell me.
No, sir.
Okay, good.